Hello, my name is Sean Kennedy, and I'm here to talk about my Sudoku puzzle. So I chose Python to write this out in, and I chose two-dimensional lists for my data structure. I felt that was pretty intuitive, and we'll go ahead and get started. So my print board function here, this just prints the board row by row. Column, it just accesses the values in a column depending on the location in the row. Solver down here, this takes all the individual 3x3 squares and accesses the individual elements in those grids, in those boxes. And B1 through B9 is actually just putting those elements into a list here. So I have this R list down here. This holds all the possible values for a given box or for a given square, a given space. And this empty list, we'll get to that. Count loop, every time the program traverses through a different space, it's going to count this one. So the first space will be 1, second space will be 2, third space will be 3. That's how I'm going to access my boxes. For rows in board, so for every list in the list of lists, it's going to access the individual elements in there. And if those elements are equal to 0, meaning it's an empty space or the 0 space, it's going to see where count loop is. And if count loop's at 1, 2, 3, 10, 11, 12, 19, 20, or 21, then we're going to know that that's going to be our first 3x3 grid. And then we're going to add the elements of that first 3x3 grid with the elements of columns and rows, and that's going to go into our S list. So our S list is then going to be put up against our R list, and any value that is not in both of these lists is going to be put into M. And M, if it is only one value, then we know that that is the value to take place of our 0 here, and that's what this does right here. So all these ifs, they just access the individual boxes in order to do the respective list manipulations. Down here, our count loop, that's just counting up. Play again. This asks if you want to play, solve another puzzle. If you do, you can just hit Y. Any other key will return no and exit the program. Num0, this tells us how many zeros are in the board. And down here, if num0 is not equal to 0, meaning there are zeros in the board, it will call this the solver, and it will do so until there are no more zeros or until it's looped 10 times. This algorithm, if it's going to solve a puzzle, it will do so within 10 loops. So we put that there so it doesn't run forever if it's unsolvable. And down here we start a game, and if we don't want to play again, we'll just break out of it. So do the test drive here. It's going to ask you to import a puzzle. We're just going to type it, pick the puzzle we want and type it as it's shown. And hit enter. I pick puzzle 1. So puzzle 1, this is the unsolved puzzle. It has 50 empty spaces, and our solved puzzle has 0 empty spaces. Asking us to solve another, I'm going to hit yes. I'm going to choose another puzzle. We'll go with puzzle 2. Alright, puzzle 2, as we see, has 51 empty spaces. And we solved it to 0 empty spaces. Solve another. I'm going to hit no to exit out. And then I will show this in the command prompt. Puzzle 3 has 41 empty spaces, and then we solved it down to 0 empty spaces. And puzzle 4 starts with 50 empty spaces, and at the end we have 0 here. So I'm going to exit out of this, and I'll show you the file type, I guess, or the structure of the file for the puzzle. This is puzzle 1. This is how I have it set up. This is how it'll, this is what it needs to interpret. And the Sudoku junk over here, this is just all the trash that I threw out while working on this. This is just my musings, I guess, putting things down, seeing what works, seeing what doesn't, before I, came across my actual algorithm here. So that is it for my Sudoku solver. Thank you very much.